Hey, and welcome to another algorithm challenge. So for this challenge, we have something called anagrams, and this is we have to write a function that returns a Boolean indicating if the two strings compared are actually anagrams. Anagrams are words that contain the same letters but in a different order. So for example, you have taco and cato. If you rearrange the letters of taco, you will get cato. But Job and Bob, although they rhyme, they're not an anagram. Obviously, Bob has two B's. You can't rearrange Job to make Bob. As before, take a minute to pause the video and try to work on a strategy and possibly try to solve it if you can, if you have a good strategy. And I'll kind of continue onward here to explain how I would solve this problem. So first up, we're going to think about the types of approaches that we can take here. The easiest approach, but this is not efficient, would basically be, and by efficient, I mean time efficient. If we take taco and cato and put them side by side, if you think about it, we could try to create some sort of function that will observe the first letter and kind of compare it against the first letter in cato, and then compare it to the second letter in cato, and then compare it to the third letter in cato, and then kind of do something when it finds the same letter inside of taco and cato. Then we could go to A, for example, and do the same thing again, where with A, we check against C, and then we check against A. The problem with that is that that's O of n squared, because for T, we're going to run through all the letters. For A, we're going to run through all the letters. For C, yada, yada. So it kind of is inefficient because it's very slow, and it's going to get a lot worse if the words get much larger. The other option is we can go through taco once and then go through cato once and then compare them outside that after they're done. And the best part about that is that it's not O of n squared anymore. It's technically O of 2n, but we actually can drop the 2. So it's just O of n, which is great. So that's much better than O of n squared. So what I mean by that is, let's say that we have this word taco, right? We can create what we're going to call like a final object and set that equal to an empty array. And what we're going to do here is for every letter inside taco, we're going to access that as a key inside of the object. And obviously the first time, for example, if you try to do final object at t, that doesn't exist. So we're going to actually add something to that value the first time we see it. And what I mean by that is, so we grab taco, we set final object at t equals to 1, final object at a equal to 1, etc., up to the letter O. We set all of those equal to 1. After all of that, we're going to get an object that basically has TACO as the keys, and they're all going to have values at that point of 1. Then we go through cato. So in this instance, let's say that we go through each of the letters. So we're going to do CATO. So let me paste all these out. And instead of adding 1 or doing anything like that, we're actually going to subtract 1 for all of these. And what's going to happen is that, let me type all these out. After we subtract 1 for all of these, this object that has taco is now going to have 0 for T, 0 for A, 0 for C, and 0 for O. Now you might be wondering, what is the significance of going from 1 to 0? For every letter inside taco, we're going to create that letter inside of the object and increment it by 1. And so that keeps track of how many of those letters that we have. Then when we run through the second one, which is cato, we're going to subtract it for that letter. And what's going to happen is that it's going to basically even out. So that way we're back to 0. The way I can kind of demonstrate this is that if I go to cato and make it tato, for example, then instead of doing, for the first time around, instead of doing final object at C, we're going to do, final object at TATO. So the first time around with final object at T is actually going to bring it down to 0, right? Because of course 1 minus 1 is going to be 0. But then what's going to happen is that next time when we get to the second T that we have here, 0 minus 1 is now -1. So now we have -1 for T. And on top of that, since we never subtracted 1 from C, now we're going to have still 1. It's not going to be subtracted. It's going to be the same. So now we can check to see if all of the values of the keys inside of the final object equate to 0. And if they do, that's great because we know it's an anagram. If they don't, or there's any sort of difference like this, that means that it's not an anagram. So that's one way to approach this. And let's jump into how I would actually code this out. All right, so let's jump into it. So I set up the function here, anagrams, passing in string 1 and string 2. I'm actually going to make this just S1 and S2 because it's a little bit easier to write out instead of writing string 1, string 2 every single time. And we're just passing in taco and cato here. So the first thing we're going to do is we want to establish a conditional to check if the two words that are passed in are the same length, because if they're not the same length, then they're immediately not anagrams, because one word has, one more letter than the other, so they can never really be anagrams. So what we'll do, and I'll provide an example of that. So we'll create an if statement and just say, hey, if s1 dot length is not equal to s2 dot length, then immediately return false. And so, for example, if I have the word taco and I add just, I don't know, like an extra O, this now has two O's and 5 letters in total. So there's no way that like this can be the same anymore, because it'll always have one more letter than the word cato. That will immediately solve for that issue. So I'm just going to say const final object and set that equal to an empty object. Nothing to really do there just yet. As I mentioned before, we're iterating through each of these strings and kind of grabbing their letters and pushing them into the final object. And so the way we can do this is very simple. We can just do a for loop, keep it nice and simple. I put I. Actually, I'll put I. So we let I equal 0 as long as I is less than, and we'll do s1.length, do something. In this case, what we can say at first, and this isn't going to work for all situations, and we'll fix it later. So we'll do final object at s1i is just equal to 1. Because in this case, if we hit that letter, we're just adding it to final object. In case you're having trouble understanding this or have trouble with what's going on here, just as a quick refresher, what we're doing is we're iterating over the first string that was passed in, right? That first string is taco. Taco is now considered S1. So we're passing in S1 and we're grabbing it at I, right? And so that means that the first time through this loop, we're grabbing S1 at 0, which means taco at 0. Taco at 0 is just T. Then we go to S1. Taco at 1 is A. Taco at 2 is C. Taco at 3 is O. So it keeps on iterating through this. Now, what we're basically saying here is for final object S1 of I, that just basically means final object at, since we're simplifying it, final object at T for the first one. So we're saying final object of T is equal to 1. And the same thing we did here, remember? Final object of T is equal to 1, A, C, O is equal to 1. So we're setting all of these equal to 1. So we're incrementing for every single letter. Now this comes with a problem, because what happens is that, let's say that we don't have the word taco. Let's say we have the word paper, for example. Paper has 2 P's. So if we go inside of this and just say, hey, final object at P is equal to 1. So we counted the first P in the word paper. But then when we get to the second P in the word paper, we're going to set final object at P equal to 1 again. So that doesn't work because we need to increment it. There's 2 P's inside of paper, not 1. So if we just set it to 1 both times, we're going to have an issue. So the way we solve for that is, and let me kind of clear this up a little bit, take out this console log. What we're going to do is we're going to say if final object at S1i exists, if this is truthy, then what we're going to do is we're going to do, again, final object at S1 at I is going to be plus equals 1. So that way, in this case, the first time with paper, right, the first P doesn't exist, so it's going to set it equal to 1. The second time around, when we hit the second P, it's going to say, hey, final object at P, oh, you do exist. Okay, so final object at P plus equals 1. So now P for that object is going to be 2. So we're able to actually count it. So we'll put that as if, and then we'll set this as else. We set this else so that way if it doesn't exist, then we just kind of declare it here at this part of the function. Okay, so that's good. Let's see what we have so far. So if I console.log final object, you can see, okay, what we have, T1, A1, C1, O1. So that's great. Okay, since the I is locally scoped for lines 5 through 8, it doesn't matter if you use I again here. Like you could use I again here and it'll be fine because I is starting at 0 again, so it doesn't really matter. And I doesn't exist outside of this for loop. So for example, if I were to console.log I here, I is not defined because it only exists within the confines of this for loop. So once that's done, I doesn't exist anymore. Who's I? So now we go to the second for loop here. So we can set it again as, for let I. Okay, so now for this situation, what are we doing? We're subtracting, so let me just I forgot to put S2 here. Okay, so we're taking the second string, and for every letter that we see, we're subtracting it if it exists. So in this case, all we have to do is just say if final object at, and we'll say S2 of I is greater than or equal to 0. We're going to grab final object at S2 of I, and we're going to do the opposite. We're going to subtract it. So we're going to say minus equals 1. So now we're subtracting it away from that. So now you can see that for taco, everything went back down to 0, T-A-C-O. And what we can do to test that is, remember what I said before with the, what I put like tato? So if I put tato, we got -1 for T. So that shows you that it's not equal anymore. We have a heavier weight on the T. And now this C, since we took the C out of cato and put a T instead, this C is now 1 because it was never subtracted. So it creates this, this weird object that has -1, 0, 1, whatever. But if I put this back to cato, everything's now equaled out as 0. So in the end, if it is an anagram, everything should be 0 on this because for all the letters that we put in, we took them out with the second word equally. So how do we check that? Well, we do a third for loop. And again, this isn't, you might be thinking, okay, is this considered like O of n cubed or something? It's not, because what's happening is that, again, we're going through each of these for loops individually, and then we're outputting a result. We're going to do a for in loop because we're going to be working with objects. And I specifically want to grab the values inside of all of these objects. So we'll just call it const key. We can keep it as key. I usually like sticking with that one because it's easier for me to remember. And instead of in object, we're going to use, final object because that's what we're actually using. Get rid of all this placeholder text. And so what's going to happen is that if I console.log the actual final object at key, you can see that we're getting basically all of the values that were inside the final object. So if I just console log, for example, final object, you can see again T0, A0, C0. So we're grabbing the values inside of this object. We don't really care about the TACO, we just care about the zeros because we want to make sure that they're all zeros. So all we really have to do is just say that if final object at key is not equal to 0, then return false. That's it. And if we pass every single other case here, all we have to do is just return true because we went through everything and we were able to get to the end. So if we get to the end, we know that we are solid. So let's try it out here. I want to try it out with the word paper because, again, that has, 2 letter P's. So let's do paper. You can see for paper and cato, obviously it's false. But if I do, let's just say, REPAP, we get true, repap. So what's happening is, even though there's 2 P's here, it's able to add the P twice and then subtract it twice. So it basically equals out to 0. But if I do you see that P is -1 because we have an extra P there. So it was subtracted 1 extra time. So hopefully this made a little bit of sense for you guys. And, hopefully it's a nice challenge for you. Again, as always, if you like the video, please be sure to give a thumbs up, comment, and subscribe. It helps the channel to grow. And we'll be going through, again, more algorithms and different data structures in the near future. So definitely appreciate you guys sticking to the channel and being loyal viewers. Thank you. I'll see you on my next video.